Okay, so we will proceed discussion in how to pseudo calculus problems. Okay, so we will proceed discussion in pseudo calculus problems. Okay, I believe it should be over soon. So the concept is that how to find the surface area of a circle and perimeter of a circle through repeated summation. Through repeated summation, how we can find the area of a circle and how we can find perimeter of a circle. Area of a circle, perimeter of a circle, we have already computed through the repeated addition. And area of a circle repeated addition means if I divide this circle into many parts, how I can divide circle into many parts in a way that there is a radius like this. This is x-axis, this is y-axis. This is radius, and when radius moves like this, it makes angle theta. This is hybrid model of Cartesian coordinate system and polar coordinate system. Okay, if radius moves from x-axis, if this is x-axis and radius moves from the x-axis, then we consider this is first part, second part, third part, fourth part, like that. We divide circle into n part. Okay, what is n part is radius is placed at x-axis. If radius is placed at x-axis, then this is first part, this is second part, this is third part. As far as red area is concerned, this is the arc of the circle. This is area of the circle. First area, second area, third area, like that. Then we have n minus 1th area, and then finally nth area. Similarly, this arc of the circle I can divide into many parts. First part, second part, third part, fourth part, fifth part, sixth part, seventh part, and into n part. Now we have learned that any part, if I take the arc of the circle, where I have divided this arc of the circle into n number of parts, if I have divided this into n number of parts, if I talk about the ith part, this is the first part, second part, third part, ith part. What is the length of this arc for the ith part? Ith part, this is, if I consider this as a center, this can also be a center where we have seen if I have a circle which equation is r equal to cos theta. Many people would not have heard that there can be a circle where r equal to cos theta and r is in variation to theta. Generally, people consider r is constant. If I talk about circle, then r is constant and theta varies from 0 to 2 pi. People never imagine that there can be a circle where r changes when theta is changing. Then it cannot be a circle. This is what people generally think. If I say this is a circle, immediately people imagine that this is the center of the circle, or this can be origin of the coordinate system. This is x-axis, this is y-axis. And when radius is moving like in angular fashion, changing its angle, this is the circle. But circle can be drawn like this also. Okay, this is x-axis, y-axis, and this is the circle. Equation of the circle is r equal to cos theta, where this is the r. This is origin, and this is the r. R is proceeding if theta is changing, but r is decreasing. Can you see? This is the r. Right now, r is diameter of the circle. When theta is growing, r is reducing. This is the r distance. Then r is reducing. When theta is 90 degree, r is completely zero. When theta is more than 90 degree, then r would proceed in this direction. Then r will be negative. To make r positive, we change the r into exactly 180 degree, opposite direction. Negative is not a separate thing. There is no difference between negative and positive. I believe hundreds of times we have repeated this. There is no difference between negative and positive. Negative and positive are same entity. What is difference between negative and positive? Means there is nothing called negative. Negative is positive only in reverse direction. That's it. Direction is reverse. So negative and positive, they settle down in vector terminology. If someone understands vector, there negative and positive are same thing. Only thing, negative direction is opposite direction. So if radius is moving This is x-axis and radius is moving like this. When angle is 90 degree, r equal to cos theta is a function. Then r equal to 0 when theta equal to 90 degree. When theta is proceeding 90 degree, radius is negative. If this is the negative direction of radius, just opposite is the positive direction of the radius. In that fashion, radius will start growing. Though angle is growing in this fashion, angle start from 0, 0, 45, 90 degree, then 135 degree, 180 degree. Radius, rather than moving in this direction, that is negative, radius will start this direction, that is positive. So angle, we can say now it is 135 degree and 180 degree. This makes a circle if r equal to cos theta. In that function, r is function over theta, whatever it is. Now we are talking, if I divide the circle into n different part circumference, then this is the ith part. This is the first part, second part, ith part. This is the ith part. If this is the ith part, then consider this angle is delta theta I. If from x-axis angle is theta, from theta it proceeded delta theta I and it made a arc, that is the ith section arc. What is the length of this arc? Okay, we cannot say it is r delta theta I because r is changing. Here r is this. After delta theta r can be like this much only. This is the r delta theta I. This is r, and if it proceed like this, then this is r delta theta I. But we are talking about this arc, because arc is changing. Radius is changing when angle is changing. In that fashion, we talk that if this is the arc, or little bit I'll grow it, but it will not be same as this. If this is the arc, then consider this arc. If someone draws from here and here arc, not a straight line, arc. The way we have circle like this, r equal to cos theta. If I see, then here is the radius. If I move angle, radius is here. Radius becomes smaller. Here radius is bigger. So this is the arc. In that fashion, if this is x-axis, okay, in that fashion, if I say this is x comma y, this is x1 comma y1, x2 comma y2. This is what we are using now. This is x-axis, this is origin. This point is x comma y, and then circle moved to another point x2 y2. In that fashion, there is a change in x that is seen, that from x to x2, x minus x2. There is change in y it is seen, that is y2 minus y. If I leave this minus and plus fundamental, x change, if I consider x change delta xi, I means the kind of subscript I, delta x bottom right small I, delta xi. If x is changing delta xi, y is changing delta yi. If I draw a straight line, this will become hypotenuse of this triangle, and that is delta xi whole square plus delta yi whole square root. That equation does not matter if radius is same. If radius is same, still delta x whole square plus delta y whole square root will be the hypotenuse. If radius is changing, radius become like this. If there is a delta theta I moment, still it will be delta x whole square plus delta y whole square root. It will not change. If angle change, if the radius is function over theta, means it is static. In that fashion, now we have found that the straight line length, if I consider delta theta as very small, infinitesimally small, in a way that we have divided the circumference of circle into n parts and n tends to infinity, very small. If it is very small, then we consider this arc as a straight line. This is just assumption. In that fashion, this angle, in that fashion, this the arc length, the ith section arc length. Okay, if I consider this as the origin, then ith section arc length. Or if I consider this as origin, left side as origin, r equal to cos theta circle equation. If we consider this as origin, then again ith part, it will come like this, converge here. If I consider this as origin, then it will converge here, whatever it is. That is delta. So now we can write the full circumference of a circle is summation sign I equal to 1 to n, and then other side will be the arc length of the ith section, that is delta xi whole square plus delta yi whole square root. Anyway, if I do summation of delta xi, where all delta xi are non-overlapping to each other, mutually exclusive, means if I see here first section, then this is delta xi. If I see second section, I'm sorry, if I see the first section, this is delta x1, second section delta x2, third section delta x3, fourth section delta x4, like that. If I do like this, then this summation can be turned into dx whole square plus, because if I do summation I equal to 1 to n, where n tends to infinity, delta xi, it will turn into dx, where limit will be 0 to wherever x is going. Now here limit will be x will be minus a if this is a circle. If I consider this as origin, then x will be 0 to 2a. A is radius of the circle. 0 to 2a. X is 0 to 2a. Or if I am moving from this side, then 2a to 0. And then square root of dx whole square plus dy whole square, where y is function over x. Y and x are orthogonal to each other, that is true. But internally they are depend upon each other. If I draw a circle, x square plus y square equal to a square, y equal to square root of a square minus x square. Okay, if someone settle it down, then he will really get the parameter of the circle, that is integration of x from 0 to 2a square root of dx whole square plus dy whole square. Okay, if someone would say, if I move 2a to 0, I am calculating the only the half of the circle. That is true. You have to multiply by 2 to get the bottom part also. Anyway, so this is now concept is arising. Why we are talking elongating this discussion? The people would not agree. Where they would not agree, they would say that the approximation you have done for the ith section arc is delta x whole square plus delta y whole square, but that will be a flat line, not the arc line. How I trust you that whatever the ith section arc length you have calculated, a square root of delta xi whole square plus delta yi whole square is perfect, because we calculated that if this is the radius, and then radius, if this is the radius, at any moment a radius moved delta theta I, this is delta theta I. If I have said delta xi, this is delta theta I. If a radius has moved one location to another location and angle is delta theta I, then what is the arc length? But radius cannot be constant. Radius decreased when it moved. This is the arc now. Okay, in that fashion, we said if this is x and this is another x when radius move, there is a change in x, that is delta x in ith section. And if it is y and this is y, then there change in y. This is delta y, this is delta x. Delta x whole square plus delta y whole square will give this. This forms a triangle, right angle triangle. This is the hypotenuse. This gives the hypotenuse length, that is delta xi ith section whole square plus delta yi whole square root. But this hypotenuse is a straight line, not the arc we are talking. How I believe on you? Anyone would say. Then we came to a fundamental that boss, let's settle down. How to settle down? Settle down in a way that if this is the arc, if if the ith section we are talking, if ith section we are talking, consider this is the origin. Consider this is the origin. In that fashion, this is any moment, this is the radius. Now radius moved from here to another point here. This is the arc we are talking. Okay, this is x-axis, this is origin. Radius moved here. If radius moved here, then from here, then radius moved little bit more. Now, this arc, what it is making from here to here, this is the ith section arc. Now, what is the length of this arc through another way, through the proved way? If I find out, then I will recheck our estimation, that repeated summation estimation, what we are boasting that it is very perfect. You get the ith section length and add all the section, you get the perimeter. Okay, then one proved way is that We try to find out the vector representation of a curved line. That is possible. No, no, no. Vector is only straight line. What is your straight line? Vector is always a straight line. What is your straight line? Like 2i plus 3j. This is the equation of a vector. 2i plus 3j. This is the equation of a vector, where it is passing through origin and passing through a point called 2 comma 3. This is a vector. True. If I say the vector, if I say the vector is xi plus square root of 1 minus x square j, then no, it is not possible. This is a vector xi plus square root of 1 minus x square j. Try now. Okay, let's try. When x equal to 1, then it will be I. Let's try. Let's draw it. This is this is this is origin, and this is x-axis, this is y-axis. Now when x equal to 1, xi plus the square root of 1 minus x square j will be I. Means this is I vector 1. It will be I means length 1. So here is the point. Okay, let's say x equal to 0. Then it will be I section will be 0, 1 minus x. It will be j. It will be here. X is 0. When x is 1, then it is here. When x is 0, then it is here. J. Okay, let's consider that x is 1 by a square root of 2. Then it is 1 by square root of 2i plus 1 square minus, we have said it is square root of 1 minus x square. It will become again 1 by a square root of 2j. 1 by a square root of 2i plus 1 by a square root of 2j. When x is 1, it is touching here. When x is 0, it is touching here. When x is 1 by a square root of 2 in between, then y is also 1 by a square root of 2. If I keep drawing all the points, it will form a circle. It will form a circle. Where is your vector then? Then vector is like this. Okay, I am taking out y-axis. When x equal to 0, vector is I. When x equal to 1 by a square root of 2, then vector is like this because it has I and j constant. When x is 0, then vector is j. So vector is rotating like this. Make sense? This is called algebraic vector. So vector can represent a movable item, may not be a straight line, may not be a straight line. Okay, this is one, we have given a hint of a vector. Okay, now consider vector is movable because x is changing. What is the vector representation of a curved line? This is not a vector representation of a curved line. A line that is moving around the center. That is a radial vector. What is this perimeter vector? If this is the line is going like this, how the vector would represent this curved line? Then curved line at this point vector will be like this, j vector. On x-axis, when x equal to 1, this point, earlier the vector was I vector. Now I want j vector. Then vector will go like this. Vector will start changing its direction like this. The way we are decreasing x. This is x-axis, this is y-axis. This is origin. If I take x as maximum, then vector will be like this. If I start decreasing, the x vector will start moving like this. And when x is 0, then vector will be minus I. It will go like this. When x is negative, vector will go. Vector will go along the line. What is the vector representation of a line? That is a big question. We have talked in the last section also. What is the vector representation of a curved line? Through pseudo mathematics, we try to find the vector representation of a straight line. If I say, what is vector representation of a straight line? What is vector representation of a curved line? Consider there is a point here called x comma y, and there is a point here called x2 comma y2. What is the vector representation of a line connecting x comma y and x2 comma y2? That is a straight line like this connecting these 2 points. That vector will be x2 comma xi vector plus y2 minus yj vector, x2 minus xi vector I plus y2 minus yj if it is connecting x comma y and x2 comma y2. That is a vector. What is the length of this line section from x comma y to x2 comma y2? Length of this line section is x2 minus x whole square plus y2 minus y whole square root. whatever vector we have found it connecting x comma y, x2 comma y2, if I calculate the magnitude of this vector, then this vector will give, then this will give the length of the section. But what we want is that we want length of parameter. But first we will describe the length. This is also called curve length vector. What we deduce is x2 minus xi plus y2 minus yj. This is typically called straight line vector. What is curve representation of this vector? Connecting point x comma y to x2 comma y2. It is not a straight line because this is a curve line. Connect this, what is vector representation of this smooth curve line? Vector will keep changing. It will not be a straight line. It means it will be in form of function of x because x is changing around the x-axis. In very simple term, there can be many philosophy around it. In very simple term, we can say that same what we did x2 minus xi plus y2 minus yj, same thing will be vector representation for the curve line. Someone would laugh at it. Not possible. That is vector representation of a straight line. Okay, what is difference between a straight line and curve line? Anyone would ask. A straight line, if I talk a straight line, this is x-axis and there is a straight line. Everywhere y by x, any point if I take on the x straight line, y by x will be constant and will be numeric. But if it is a curve line, then everywhere y by x will be different. Means y by x is variable in curve line, whereas in a straight line, y by x is constant. So I can take xi plus yj, no problem. If there is a line connecting origin and point x comma y, I can take it as xi plus yj, no problem. But if I try to represent a curved line through a vector, y by x has to come in the vector because that is variable. In that sense, we take out x from here, xi plus yj. If I have a line connecting origin and x comma y, this is a straight line, but I want curve line, then curve line will come with, if I represent this a straight line vector into y by x, because y by x is variable need to be represented. In that sense, xi plus yj is the vector form of a straight line. I take out x, it becomes I plus y by xj into x. Okay, now y by x is not y by x. If I say y by x, then it is, we have demonstrated it many times. If I have a division of two items and numerator is dependent upon denominator, it will be turned into differential calculus. So it will become I plus dy by dxj bracket close into x, multiplication of two items where one is dependent upon another, I plus dy by dxj, which will come in form of x only function over x, and it is dependent upon another one x. It is now integral calculus. Now, full become the representation of a curved line that connects point 0 comma 0 to x comma y will become I plus dy by dxj bracket close into dx. This is the representation of a curved line. Okay, if that is the case, then we are trying to find the the vector that represents this curved line. The vector that represents this curved line, if I had taken a point x comma y and other point x2 comma y2, the straight line representation is x2 minus xi plus y2 minus yj. Curve line representation is, if it is in term of y by x, I'll take out x2 minus x1. It will become I plus y2 minus y by x2 minus xj bracket close into x2 minus x. Okay, it is fit case for differentiation again. Now we will remove x2 and y2 fundamental. It will become I plus dy by dxj bracket close into dx. Is it the vector representation of a curved line? Certainly, this is the vector representation of a curved line. Anyway, so the vector representation of a curved line for the ith section is same thing. That is I plus dy by dx j bracket close into dx. This is also called length vector. This is the length vector. If I calculate, this is the vector representation of a curved line. Ith section. If I talk about ith section, then at ith section, this is the, if I talk about the perimeter of a circle, then this is the perimeter of the circle. This is the first section. This is the second section. This is the ith section. If this is the ith section, then this point is, consider this point is x comma y. It makes intersection at x axis at point x. Now we have said that our curve line equation, that is the arc can be like this also. Curve line equation, that is the arc, is I plus dy by dx j bracket close into dx, where dy by dx, when we calculate, it is at point x, where this is angle delta theta I, very small angle it makes, and we are trying to get circumference of the ith section, where it begins at a point called x, where this is x axis and this is the point touching the x axis, the arc point of the circle. This is x. If this is x, then we have to, or someone say no, this is alpha. Okay, then I plus dy by dx calculated at when x equal to alpha, and then dx. Okay, dx. So some we will see it. Then dx. Okay, if that is the case, then someone say, okay, why you are doing this much? Break it. You can break it. Okay, we will break it. I am not running away. If you break it, it becomes dxi plus dyj. So vector representation of the ith curve is dx or delta xi section I vector. This is I as a subscript is the ith section. I is I vector delta x. We have I plus dy by dxj bracket close into dx. If I break it, it becomes dxi plus dyj. If I talk about the ith section, the dx I can break it into delta x. Okay, then it will become delta x of the ith section I vector plus delta y of the ith section j vector. This is the vector representation of curve of the ith part. What is the magnitude then? Then any vector, if you calculate the magnitude, it will calculate the magnitude through the square root. It will become like delta xi whole square plus delta yi whole square root. It is exactly same what we calculated the ith section, where we took this as the arc, and this is delta x and this is delta y, and arc length will be a straight line effect. Exactly same thing. Means it works. Okay, it works. Anyway, now someone would say, can you compute it? The way you said, through that, can you compute the circular length? Okay, we will try. There is no harm in trying. What is your circular length now? Okay, if I compute the circular length through pure integration, then it is I plus dy by dxj bracket close into dx. Magnitude of this vector is the vector along the line. If I calculate the vector magnitude, it will give the line length. Magnitude of the vector that represents a curved line, that is I plus dy by dxj bracket close into dx, it will give the curve length. What is its magnitude? That is I square, means 1 square plus dy by dx whole square root dx. What is dy by dx? Y equal to square root a square minus x square, considering a is area, a is radius. Then it becomes square root 1 plus dy by dx whole square become x square by a square minus x square. It will become a by a square root of a square minus x square dx, where x is from minus a to a. Okay, if someone calculate, then he would get no. All right, I understand. It will come as pi r, because half we are calculating. X is moving from here to here, half we will get. We will double it. No, not that I want. Can you calculate for r equal to cos theta, where r is function over theta? But you said it is in dx, dy, dz, or something like that. I want in a fashion that it is a sign, it is a kind of r equal to cos theta. Okay, we can do in many ways. We can do in many ways. What is the fundamental of calculating the? Then we will calculate again. Okay, but we calculated it in x and y. Okay, you want in r and theta, right? Okay, yes, we want in r and theta, because r is function over theta. In that fashion, consider this point is x comma y, this point is x2 comma y2. Let's do in polar coordinate system, because you said in polar coordinate system r is function over theta, certainly. Now in that fashion, the center of the circle is here. Center of the circle is is here. Up, here. And this is r equal to cos theta. This is the origin. Now in that fashion, if I take any point here x comma y and x2 comma y2, now I have to represent these 2 points in polar coordinate system. Then this point will be r. R is the radius from here, r, and theta, because these are the two independent components in polar coordinate system, r comma theta. But this cannot be theta because this is the length point where this is r, then theta has to be in length only. One is r comma theta is angle. Theta has to be in length. So length representation of theta is r theta. R theta, that is the length representation in abstract manner. It may not be very correct when r is function over theta, but in abstract manner it is r theta where r is constant. So any point here I can take as r comma r theta. Another point is r2 comma r2 theta 2. R2 comma R2 theta 2. This is another point. Okay, in that fashion, then if I draw a line and then more or less what is the vector representation of a straight line if it is a polar coordinate system? Then it will be r unit vector plus r theta theta unit vector. This is in synergy with the xi plus yj. What is the vector representation of a curved line? Considering theta as variable, theta is varying. Then I have to take out theta. There I took out x and making y by x because y by here I'll take out theta. Considering theta is variable and r is function over theta, there y was function over x. Here r is function over theta. These are $1 trillion explanation, not available in any of the book. Okay, in that fashion it will become r by theta, r unit vector, plus r theta by theta, theta unit vector. Okay, bracket close into theta. Now differentiation, division will turn into differentiation. Then it will become dr by d theta, r unit vector, plus r theta unit vector. Bracket close into theta into d theta. This is the in polar coordinate system. This is the representation, vector representation of a curved line. If that is the case, then what is magnitude of this? That will be the curve length of the ith section. What is right now? It is dr by d theta, r unit vector plus r theta unit vector, bracket close, into d theta. Okay, can you settle it down? If I settle it down, it will become dr r unit vector plus r theta, r d theta, theta unit vector. If I break it down, what are you saying? Okay, I am saying it right. This is the vector representation of in polar coordinate system of a curved line. That is r, I'm sorry, d r r unit vector plus r d theta theta unit vector. For the ith section, if I talk in the vector representation in polar coordinate system, then it will become delta ri ith section, r unit vector plus r delta theta I theta unit vector. What is delta theta and delta r? Delta theta and these are not there in any of the book. Now consider that this is origin and we are at one point here. Then radius is moving from here and it came here. Radius becomes smaller. Now if I take it out, then it becomes like this. This is r and this is another r. Radius becomes smaller when I move this r. This is the ith section of the circumference. We are saying this circumference vector, the arc vector is delta r unit vector plus r delta theta unit vector. What is delta r? Delta r means if this is r and this is another r, how much r is changing where angle is delta theta I. Makes sense? Now it is converted into delta r of ith section. For the ith section, how much r is changing? Delta r is not changing. Who said that r is changing? Then this factor is 0. Okay, then vector representation will be r delta theta theta unit vector. That's it. No, radius is changing. This is not available in any of the book. Anyone can check. What is the vector representation of arc in polar coordinate system for the ith section? That is delta r I, r unit vector plus r delta theta, delta theta I, theta unit vector. This is the vector representation where delta r is how much r is changing in the ith section. If I take the circle, then this is the first section, this is second section, this is the ith section. For the ith section, how much radius is changing, then how much theta is changing, that is delta theta I. The vector representation of this curved line is delta ri, r unit vector, plus r delta theta I, theta unit vector. Okay, thank you very much. What is the length of this curve? Length of this curve is magnitude of this vector. What is magnitude of this vector is? Magnitude of this vector is delta ri whole square, plus r square delta theta I whole square root. That's it. Means if I add for all the section, it will give me the circumference. You are saying yes, it will give the circumference. Tell me this repeated summation equation. Repeated summation equation is summation I equal to 1 to n square root delta ri whole square plus r delta theta I whole square, or someone can say ri, ith part. What is the r? Ri delta theta I whole square root. This will give this will give the circumference. Okay, convert into integration. Now we can convert. Delta r will become dr, and delta theta will become d theta, and now integration will be become for the full angle where r is function over theta. Okay, now we have integration square root dr whole square plus r square d theta whole square. Now if I take out theta, it becomes dr by d theta whole square plus r whole square root d theta. This will give the circumference of the circle, certainly. If I have r variation in theta, then theta is going 0 to pi. That at the beginning only we have told. Now theta is 0 to pi. Theta is 0 to pi, and then square root of dr by d theta. What is r and theta? R equal to cos theta. Dr by d theta is minus sine theta whole square plus r square cos theta whole square, all gone. It becomes d theta only, and that is 0 to pi. Pi is the circumference of the circle when it goes 0 to pi. Certainly it is pi only. Okay, the circumference is 2 pi r. Circumference is 2 pi r generally. This circle what we are drawing r equal to cos theta is a circle which has radius as half. Radius as half, and this is origin. That is 2 pi r. R is half, pi only. So it is perfect. Anyway, let's proceed. Now, we said that at the beginning when we talked about the general approximation of the ith section, that came as delta xi whole square plus delta yi whole square root. Now can I bring it into the kind of form of r and theta? Certainly someone can bring delta xi whole square plus delta y whole square root, del x equal to r cos theta. In general term, the polar coordinate and Cartesian coordinate mapping is x equal to r cos theta, y equal to r sin theta. Delta x will become r into d cos theta by d theta, delta x, plus cos theta dr by d theta. Okay, this is the delta x. If x equal to r cos theta, where r is function over theta, dx will become r d cos theta by d theta plus cos theta dr by d theta. Delta y will become r d sin theta by d theta plus sin theta dr by d theta. We can place it there. Delta x whole square plus delta y whole square root. If someone settle it down, it will exactly become a square root of dr by d theta whole square plus r square outside d theta. Someone can try it. Means whatever we brought through our vector concept dr by d theta whole square plus d theta plus r square root d theta, exactly it will come through approximation also, where we dreamt that any ith section arc is delta x whole square plus delta y whole square root. There we started the repeated summation. Through both way, we can come to same region, and it is perfect. Okay, we will proceed on this, I believe, one more session where we will see similar thing in area also, and then we will see from the normal approximation, summation approximation, and from the integral vector way, both come to the same location, means normal approximation work. Why normal approximation is important? Normal approximation is important because it is easy to think about. It is very easy to think about where we divide our complex thing into n parts, and then we solve it by repeated summation, and then we come to integration. This is also one of the way where people solve any problem. Whatever the problem is, divide into many parts, make it as a summation and calculate the ith part, sum it, and then convert into integration and solve it, rather than going with a vector and this and that. That much is not required. I believe it is all right. Let's see how we came from vector and integration and came to summation. Summation was easy, but it should be, but there are assumptions in summation. That is the problem. Otherwise, if I come from vector and calculus, there is no assumption here. That is exactly perfect. Anyway, please don't mind supporting us. Plus line 1 is the India country code, 9483160610 is the telephone number. Plus 91 is the India country code, 9483160610 is the telephone number.